let's talk about the data quality dimensions. That is, when you're fixing data and identifying a data quality issue, an issue is not global. It depends on the dimension that you pick. For example, the completeness dimension dictates whether data are present or not. So the data set that is missing data has low quality according to the completeness dimension. But for example, the accuracy dimension is all about whether the values make sense or not. So even if data are complete, they may not have values that make sense. So they are of low quality according to the accuracy dimension. Let's take a look at these two dimensions and many others that can be used to identify data quality issues. When we're talking about data quality and about data being high quality or low quality in specific, we may mean different things. And this is because data quality can be measured according to different criteria, which are known as the data dimensions. The most relevant data dimensions include, for example, first of all, completeness. That is, how many values are missing. This is the quote-unquote usual data dimension that comes to mind to most people when they talk about data quality. What are we missing in this data set? Next comes accuracy. That is, do the values that we have actually make sense? Are they within range of what's considered acceptable? You may have 10,000 records of temperature readings, all of them with complete information, but some of them may have ridiculous values, such as being -1 or being 999. They are complete, but they're technically not accurate. Then we have consistency, and this is crucial when dealing with multiple data sources. That is, throughout the different data sources, are the data the same? For example, if you have 10 repositories of customer data, are they the same customer data? Or even at different stages of the same process for the same data? That is, are the raw data in the same format than in the data reports or other data products? Or did something happen along the way? Another relevant dimension is timeliness. That is, how up to date are these data? And how frequently are they refreshed? This may be crucial for financial systems with thousands of trades in real time, or for example, healthcare institutions performing surgery and other interventions that need to consult patient allergy information, for example, in real time. Another very important dimension is lineage. That is, where did these data come from? Are they trustworthy? And what happened to them at every step of the way? That is, documenting every single change that the data went through, by whom and when. It's about tracking the data, if you will. Let's start with the completeness dimension in further detail. This one is very easy to explain. In a list of values, you want to know how many are missing. Or instead of full records being missing, which records have a specific field or a specific combination of fields missing. For example, we may be talking in a list of customers about customers that are missing, but we may also be talking about a list of customers that all exist, but 15 of them, for example, missing the address field in specific. These are completeness problems. Or, for 100 clinical trials, only having documentation for 80 of these. This may be an issue of files, not database fields, but it's still very much a completeness problem, regardless of the type of data source. Then comes the accuracy dimension. This is the next most frequent one. That is, whether the values present make sense or not. And this can be subjective to measure, and it depends on how defined the data rules and expectations are. For example, you have a zip code field that must be composed of 7-digit numbers, and out of 100 fields, 10 records have the zip code in a different format. That is an accuracy issue. Or the example that we mentioned. We have a temperature field in Fahrenheit units, which therefore should have values between 0 and 100, but you have some values below 0 or above 100. They're not accurate values. The consistency dimension is all about whether information is the same across different data sources which should have the same data. That is, in reality, do the data match or not? There are initiatives such as master data management or other frameworks that aim precisely to always establish one centralized source of data. But realistically, in any company, there are always copies of data and duplicates, and these may not match for one reason or another. Maybe they're not updated, maybe someone made a typo, and so on. To illustrate this, Let's say that you have a list of employees in a central HR database, and you also have the same list of employees in a local trading database. Are they the same or not? Or you may have sales data in a report versus sales data in the original database. Do these have the same values? Then, the timeliness dimension measures how updated the data are. This can be important in fast-changing environments or in environments where the data has specific retention periods or the industry is heavily regulated. For example, in a financial trade database, which processes thousands of transactions per second, a transaction that was reverted 5 minutes ago, not having been updated yet, is a significant problem because other trades may depend on it, or it may change the available asset value, which counts for the collateral for other possible trades, and so on. Then the lineage dimension deserves its own mention, and this is one of the most important ones, especially for regulated data. This dimension cares about the full path of the data from origin to present. It includes the creation or capture of the data, all the way through the transformations applied and the people and systems involved. For example, if we obtain data from a third-party vendor and they were cleaned up and loaded into an operational database, then went through an extract, transform, load process and loaded into a data warehouse, do we even have that information? What specific changes occurred at each stage, and who was involved in each? Do we even know that? Please notice that in many cases, it's not just about knowing where the data have been, but applying a kind of trustworthiness score to the data sources. And I mean both to external vendors and internal sources. Asking yourself, for each data source, do I know enough to trust these data? Is this vendor trustworthy? Is this data source trustworthy? For heavily regulated industries, in particular, that use data for model calculations, it may even be demanded by regulators that a snapshot of the calculations at the time with all the data involved at the calculation time be saved and kept aside. To give you an example, banks have what is called regulatory capital, and that is a cushion of capital to be set aside to protect against losses demanded by regulators to make sure that the bank doesn't go under. In other words, the regulator is forcing the bank to stay healthy whether they want to or not. But naturally, this is inconvenient because that capital must be in reserves and can't be invested. So the higher the amount of regulatory capital, the more the bank is protected against losses, but the lower the profits. So banks historically have been very smart and they underestimate the regulatory capital amounts. And they may even twist the calculations that result in that capital. For example, the total amount of regulatory capital usually relies on adding up what are called the risk-weighted assets, which are sets of assets with a risk weight for every one of them. For example, risky loans have a certain risk weight, secured loans have another risk weight, and so on, and you add all of that up. So for example, a regulator may calculate that a bank needs 5 billion in regulatory capital, but the bank may calculate 4 billion. So what happens is the regulator may demand the bank to not only store the data for the final calculation, but all of the risk factors and all of the asset sizes at the time involved in the calculation. Or the same for loans, for example. Banks make lending decisions based on a lot of factors, and a regulator may want to examine these. So besides saving the decision in terms of the loan, the regulator may also demand the bank to save all of the factors at the time of the loan. These are all problems in terms of data lineage, tracking what data exist, what transformations they went through, and who was involved in each. It's important to be aware of these different data dimensions because projects that aim to improve data quality may be referring to different dimensions in different situations. For example, our business intelligence reports are producing bad results. Is it because we don't have enough data? So is it a completeness issue? Or is it because the values don't make sense? So is it an accuracy issue? Or is it because we have old data that doesn't represent the present, which is a timeliness issue? Or for example, we're getting fines from regulators as a bank because our regulatory capital models used the wrong numbers. Our example, is this an accuracy issue because we don't have the right values? Or is it because we didn't even record those numbers at the time, which is a lineage issue? Usually, the projects used to improve data quality may intervene at any of these dimensions, and in some cases, multiple at once. It's important to note here that despite the dimensions mentioned being the most frequent ones, this is not a complete list by any means. For example, other dimensions may include, number 1, identifiability and accountability, that is, whether each individual piece of data, each datum, has a specific group or a specific user associated with it or not. For example, this is crucial for data governance. Each dataset must have an owner, period. Another example is presentability. That is, whether the data presented are easy to visualize or not, regardless of their values. For example, you may have two columns, one with expenses and one with profit, but the profit one is in a character format instead of a number format. So although the information is there, you can't plot it visually because you can't plot numbers against character strings. So the information is complete and accurate, but it's not easy to visualize. Or for example, uniqueness, whether the data are unique or whether we have duplicates within a specific database or another storage format, and possibly others. Also note that depending on the organizational needs, you may create custom dimensions, which are usually a combination of existing ones. For example, you can measure data completeness and accuracy as one. You do profiling of a dataset, and you calculate all records which are both complete and make sense versus all others, which may not exist or may exist but not be reasonable. Or for example, you may combine data which is accurate and has lineage information. For example, you may have a criterion of only accepting a data source as trusted if it's 100% accurate and it has 100% lineage information. Both conditions must apply. These are usually created on a case-by-case basis, and they're good to examine data for very specific needs. So let me run some quick examples of data quality problems. Let's say that you have a customer entity in your database. What are some data quality problems in different dimensions? In terms of completeness, an example is having multiple customer rows in the database which are missing, or they're there but they have crucial fields empty. In terms of accuracy, it's about wrong data. You may have many customer rows which are there but they have numbers instead of names in the name field. Or, in terms of consistency, maybe we have 3 data sources for customers and they all have different addresses for the same customers, and this may occur for many customers. In terms of timeliness, for example, we may have customer data which is complete and accurate, but it's from years ago. Or, in terms of lineage, we may have a customer report, but we may have no idea how the data got there, how they were modified, or by whom. We may even know that data were modified 3 times, but we have no idea what happened at each stage or who was involved. Then, uniqueness. Very simple. We have multiple duplicate customers in the same database. And finally, an example of identifiability. We do not know who in the organization is the data owner of the customer entity or who has been modifying it. We have no idea who we should report to when there is a data quality issue with this entity or who has the responsibility of actually fixing it. What are some examples? The first are clinical trials as an example of lineage. Clinical trials for healthcare companies are one area where the company must not only save the final results in terms of data, but in many cases, all of the intermediate steps, usually with a lot of detailed process information at each stage. Then, consistency is an organizational issue. It's an important dimension to make sure that the whole organization is aligned, that different departments or lines of business use the same data. If you get different results in terms of consistency, that's probably because the organization is not standardized. Then, the most sensitive dimension is probably accuracy, and the most subjective one, because in many cases, whether a value is reasonable or not is entirely subjective. For example, outliers. Let's say that you're a company that has old sales information before the digital age, and you only have aggregate numbers. If you have a high number at the Christmas time, for example, you may know that it may be a seasonal spike, but you may also have a very high number in the middle of the year without a justification. Is that a wrong value, or can it be explained by something else? There is no right answer. What are our key takeaways this time? The first is that there are multiple data quality dimensions. Data quality is not universal, so data may be of high quality according to one dimension and of low quality according to another one. And the data profiling and remediation Each data issue is specific to one dimension in particular, and the data profiling and remediation are done for that dimension and only that one. Two of these are completeness and accuracy. The completeness dimension measures whether there are data missing or not, and how many. The accuracy dimension measures whether the values present make sense or not. Then, consistency and duplication. The consistency dimension measures whether the values that we have are the same across different data sources. Then, the uniqueness dimension measures the presence of duplicates in a data source. And finally, data lineage and ownership. Data lineage is all about tracking, specifically all operations on data, when, and by whom. Identifiability and ownership are all about assigning an accountable owner to every data source and identifying everybody who performs an operation. So as we see, there are multiple data dimensions that act as the lens through which we identify data quality problems. Although completeness and accuracy are the most famous ones, if you will, every single one of these dimensions might make sense for a specific use case, and you have to be the one to interpret which dimension is the best one to analyze a data quality issue through.